This call is provided as a courtesy to congressional representatives, tribal, state, and local government officials, including levy sponsors and emergency managers, as well as the media. My name is Paco Ham, and I will be your moderator for today. Please note this call is recorded and placed on the Defense Video and Imagery Distribution Service for media reuse. And we will have a link that will be sent out. Your participation acknowledges your consent to be recorded. All lines have been placed on mute. To unmute your line, to ask a question, press *6. Then force mute function does not work on all phones. So if I ask, please use your phone's own mute function. Do not place on hold. We will have a question and answer session at the end of the call. And the agenda for today is as follows. The NOAA National Center for Environmental Information will have a presentation first, followed by the National Weather Service Missouri Basin River Forecast Center, which will provide an update of river stages, river forecasts, and weather forecasts. And then lastly, we will have a presentation from the Missouri River Water Management Division, which will provide an update of inflows, reservoir storage, and release plans. We will have a question and answer session afterwards. And so we hope that if you have any questions, we will be able to answer them for you. And John, I think we can go ahead and start the presentation. So if Noah is available now.
There you go. Yep, that's me. I'm Doug Cluck. I do work for NOAA, National Oceanic and Atmospheric Administration. And like I have the last 2 years, I'm going to give you a brief rundown of the situation, sort of antecedent conditions, as well as what's coming up in the future. So let's go ahead and go to the next slide. Just keep going down. There you go. So looking back at 2023, last year, this is the entire year sort of averaged together and summed up and compared to normal. So on the left, you'll see temperatures. On the right, you'll see precipitation. Departure from normal temperatures for the entire year last year, January to the end of December, showed that we had some general warmth over much of the region, warmer than normal, but some cooler than normal temperatures overall in Wyoming and portions of Colorado. But overall, for the basin, we were slightly warmer than normal, which adds to evaporation and evapotranspiration. So in other words, we were able to evaporate more water likely over that period of time. Percent of normal precipitation is up there on the right. So what percent did we have? Well, let's all remember back. A couple things that happened last year was the Front Range and some of the mountains actually got quite a bit of precipitation during the spring. In fact, they were the only ones that got precipitation during the spring in our basin. And you can see western parts of the basin, including eastern Colorado, Panhandle, Nebraska, Wyoming by far. Wyoming was sort of the bullseye. And then portions of Montana, wherever you see green, especially purple and blue, those were quite a bit above normal in terms of precipitation on an annual basis. Lower basin, it was the opposite story, and as well as sort of the northernmost portions of the basin. So lower basin, very dry for the most part. In fact, some places getting less than 70% of normal. So, and you can see in Missouri and in portions of Iowa, Nebraska, eastern Kansas all had that issue. Next slide. Now, just looking back the last 90 days, so back to, we'll say the middle of October, again, temperature on the left, and that is departure from normal temperature. So we were quite warm. We had a very warm fall into early winter, okay? Believe it or not, especially in places like Minnesota, which I know aren't really part of the basin, but even in North Dakota, that we're looking at somewhere around 6 to 8 degrees above normal in terms of temperature, but by and large, very warm when you average out, again, temperatures over that period. In terms of precipitation on the right, the percent of normal, We had some really, really big systems go through. Now, this isn't the wettest time of year, so you could argue it's not that hard to get really high numbers here, but in a couple of places, 300% or more of normal, little points there, but in large areas of over 150% of normal across the mid basin and portions of the southern basin as well, lower basin, I should say, but not as wide a coverage down there. So it helped, but it's not the end of the story in terms of drought. Upper basin, far upper basin, kind of hit and miss in terms of wetness and dryness. You can see where there's red and sort of brown and yellow. That's below normal, and green splotches is where we record above, green to blue or purple above normal for the last 90 days. So sort of varying numbers, if you will, coming into now. So next slide. Let's look at mountain snowpack for the most part. I know it's very hard to see those little teeny numbers in there. I could have blown that up. I don't know why I didn't. But anyway, that sort of oval area there is more indicative of the Missouri Basin feeder streams and sub-basins, if you will. That's the area we watch to see if the Missouri Basin is going to have a large snowpack in the mountains and such. And really, we see everywhere from 12 to 82% of normal. Lacking in snow is the basic idea here. And you can blame El Nino for some of that signal. That's common, especially in the northern Rockies, to see dryness sort of develop during winter, especially in the snowpack, right? That may change over the next week or so. We're seeing a series of storms come in, but it's probably not enough total to get us back on track at this point. Next slide. I'm sure the other folks are going to show this, so I'll be brief. That's plains snowpack for the most part. The southern part, say from the middle of South Dakota down to Kansas City, we're seeing a little bit above normal in terms of snowpack right now. That's all probably lower basin runoff stuff. Upper basin, well below normal in terms of snowpack for this time of year. Obviously, we have at least a couple months more that is potential to build on this or add to this, if you will. So it's not the end of the world. It's early in January. So plain snowpack is below normal for the upper portion of the basin and a little bit above for the lower part of the basin. Next slide. It's always important to point out soil moisture. I did a couple different things here. There are a couple different models. So nothing's perfect when it comes to soil moisture because it's not measured everywhere like we do precipitation and temperature. Thus, we come up with these modeled extrapolations. But for the most part, if you're looking at the surface moisture in the basin, you see that there is some wetness across Kansas, central Kansas and such. But also some dryness into Missouri. But as you go sort of north, really nothing outstanding there in terms of being above or below normal in terms of soil moisture. There is some lingering on the right. The map on the right, map on the right does show some lingering dryness, and you're going to see that on the drought monitor in a few minutes. Across the lower basin, there's still quite a bit of dryness there. It's going to take some time. Snow by itself often isn't enough. You can have a couple feet of snow, but when you translate that into water that actually percolates down into the soil at depth, often doesn't amount to that much. It really depends on obviously how wet that snowpack is. It also depends on if the ground is frozen and if it allows any moisture to trickle down through it. What we really need are heavier rains and such. All right, next slide. Now we're getting to the outlook portion of the talk here. So we're in a dry time of year for most of us in the plains, lower elevations. Not true necessarily in the mountains, but this is what it looks like for the next 7 days. Just 7 days, and if you add all the precipitation that can happen according to the models over that next 7 days, this is what you get. You do see some, let's talk about the mountains first. You do see some indication of wetness in the mountains, but nothing extraordinary or super high out there. They'll get some, but not the kind of values we'd like them to see. We'd like to see more red, if you will, which indicates 2, 3, 4 inches of actual water in the snow that accumulates up there. So I'm not impressed with this. In the plains, as you move kind of east into the plains, you see a few areas like eastern Nebraska, western Iowa, portions of Missouri, and a little bit here and there where some snow is going to fall. And if you're, if you're going to get 6 inches or 8 inches or 10 inches of snow, it's a big deal. I get it. But in terms of overall precipitation, not that much over the next 7 days. So next slide. This is looking at not this next 7 days, but the next 7 days after that. So we call it days 8 to 14. Temperature outlook on the left, precipitation on the right, and really quickly, below normal temperatures for the most part are predicted across the region. I would say the most anomalous cold or most severe cold in terms of normal will be in the lower basin. And then on precipitation wise, looks like near normal for the most part for the entire basin in terms of precipitation. Next slide. There's the January through March temperature on the left, precipitation on the right, outlook. We're looking for continuing above normal probabilities for temperature across obviously the northwest part of the U.S. into Montana, and then across the Dakotas and Minnesota. And then south of that area, sort of equal chances of above, near normal, or below, and a funny kind of gray area there where we just think pretty close to normal is going to happen when you average those 3 months together and come up and look at the temperature. Precipitation wise, there's a slight, both slight wet signal through Colorado into Nebraska, Kansas. It's a slight leaning towards wetness in that area, which is I'll talk about that in a bit, and dryness across the north and northwest part of the basin. So continuing, if you will, sort of dryness in the Montana area in the northern Rockies, and potentially a slight leaning towards wetter in Colorado. Both of these maps, by the way, indicate are sort of strongly linked to a typical El Nino scenario. El Nino, and again, El Nino in a nutshell is when the water is warmer in the eastern Pacific equatorial area. What happens to our weather up here? It is affected often. And what we're seeing over the next few days when it gets bitterly cold is sort of a transitory thing. We think it'll get cold and then kind of go back to, if you will, a pattern more like this. So we expect a couple cold air outbreaks over the winter. Even during El Nino, it doesn't matter if it's El Nino or a La Nina, you're going to get them. But they just don't last as long during an El Nino, and they tend not to be as severe. However, this one looks pretty bad in terms of cold temperatures in record set. So just wanted to say that. Next slide. Okay, so just looking at the drought status. And the important thing here, there's the drought monitor as of yesterday, or as of this morning, sorry. That shows you where the drought's worst or best in many places. Obviously, we have a little bit of drought in the lower basin, which we sort of mentioned earlier, and there's good reason for that. Really, if you can really focus in, and I know it's hard, on the places I blocked in there in red, you can look a year ago compared to now, and you can see that our current levels of drought are much improved since last year at this time, if you will. So the aerial coverage of, let's say, D3 to D4, which is really bad drought, has decreased immensely. The coverage of D2 to D4 drought, that entire thing has decreased immensely. And the coverage, of course, from overall coverage from all the drought levels has decreased substantially during that time. That said, on the right, you have a drought outlook that goes through the end of March. So by the end of March, these are some of the areas that if the brown sort of describes where drought is now and is not projected to get much better. And then yellow is drought may develop in those areas. So you can see for the Missouri Basin, the pretty much yellow area is the northern Rockies. There's a yellow area there that may impinge on the Missouri Basin a little bit. Otherwise, kind of status quo for the drought situation. And often in the winter, drought does change more slowly than it does in the summer, for obvious reasons, I hope. Next slide. So again, our ENSO condition is strong, a strong El Nino this year, slowly transitioning to a neutral one. We can talk more about that as the months go by. Plains snowpack is low, mainly in the upper basin. Mountain snowpack, mainly well below normal. Short-term outlook is temperatures below normal. Precipitation chances sort of near normal, if you will, over the next 7 to 14 days. And then long-term increased chances of above normal temperatures in the northern part of the basin, especially in the northern west. Equal chances of above, below, and near normal precipitation for the rest of the area, or for temperature in the rest of the area. Precipitation mainly enhanced in Colorado, slightly enhanced, let me change that a little bit, in Colorado into the Central Plains, and below normal is slightly favored in the northern Rockies and northernmost states, which is an El Nino typical signature that we see. We have a webinar coming up in about a week, actually exactly a week, that if you'd like to attend, is for the north central part of the US. We'll talk more about these things in conditions. So anyway, thank you very much. And thanks to the Corps and others for being on and inviting us to talk.
Thank you for that. Thank you for that presentation. We appreciate it. Now we're going to go to the National Weather Service.
Good afternoon, everybody. My name is Kevin Lau. I work with the National Weather Service River Forecast Center in Kansas City. As Doug mentioned, I wish to thank again the Corps for inviting NOAA to take part in this series of calls. Snowpack conditions in the mountains can be generally categorized as being well below normal. By this point in the winter, we have accumulated about 50% of the seasonal peak snow water equivalent in the mountains. And so we still have a little ways to go. So a lot could still change as far as the mountain snowpack. Oh, and you can go to the next slide if you'd like to. Thank you. The January water supply forecast developed by the National Weather Service were issued last week. And our January numbers would suggest that the April through September mountain runoff volume will be below normal. Moving now to the plains, we do have a fairly wide spread, and in some places, a rather healthy plains snowpack. Several sites in South Dakota reporting in excess of 1 inch of snow water equivalent. For the first time in about 4 years, the big story for the Missouri Basin as a whole is no longer the drought, as Doug has already alluded to. And again, that's not to say we don't have some areas that are still in drought, but according to the latest drought monitor, as Doug said this morning, less than 20% of the Missouri River Basin is now classified as being in drought, and that compares to 63% of the basin being in drought 1 year ago. Soil moisture does vary across the basin, but the lower portion of the basin, as well as extreme northern Montana, appear in general to be the areas that have the greatest soil moisture deficits hanging on. So far this water year, we have experienced very little and then only minor flooding. In late October, we had a significant rainfall event over eastern Kansas and western Missouri. It dropped as much as 8 inches in a 24-hour period, and over 14 inches over a period of about 5 days. But that October event resulted in only one tributary to the Meridocene River in eastern Kansas to exceed flood stage. And so that was back in late October. Then over Christmas, we had another event, and it occurred in more or less the same area, eastern Kansas and western Missouri. This time it totaled about 3 inches of rain. And this Christmas Christmas event resulted in 2 tributaries to the Osage River rising above flood stage. So both of these events testify to the ability of the soil to absorb much of the precipitation. But they also remind us that flooding can and does occur within the Missouri Basin any time of the year. In late December as well, we had elevated stages along the lower North Platte River due to ice. Impacts, I believe, were localized and minor. The risk for ice jam related flooding continues for the remainder of the winter and early spring seasons. Looking ahead, our office issues 90-day river outlooks toward the end of each month. The most recent 90-day outlook was ran in late December and covers the 3-month period ending in late March. And the map that you see here on this slide depicts the result of that late December river outlook at the 400 plus locations that we monitor across the basin. Our most recent river outlook would indicate that the James River in South Dakota and a couple of the smaller tributaries within the state of Missouri have a better than 50-50 chance of seeing minor flooding between now and the end of March. And those are the places you see in orange. Risk for flooding between now and late March is dependent upon the timing and location of any planned snowmelt, rain on snow events, and rain events. And again, this outlook that you see does not take into account river ice. As we near the end of this 3-month period, which would be again late March, we have to begin thinking about thunderstorm activity, and that drives springtime flooding, typically in the lower basin. The National Weather Service will be issuing its first official spring flood outlook on Thursday, February the 15th, and that will provide the first official National Weather Service quantification of flood potential for the spring and early summer. Thank you, and this concludes the National Weather Service flood potential brief.
Thank you, Kevin. Appreciate it. Now we're going to go to John Remus, the Missouri River Water Management Division.
Thank you, Paco.
Okay.
And also thanks to Doug and to Kevin for sharing those insights. Good afternoon, everyone, and thank you for joining us. I am John Remus, Chief of the Missouri River Basin Water Management Division. Our office is responsible for regulating the Missouri River mainstem reservoir system. This is the first of our 2024 monthly stakeholder calls. I will provide some general remarks, and then I will turn the discussion over to my senior staff for more detailed information. As always, I want to assure everyone in the basin that the Corps remains fully committed to our flood risk reduction mission, protecting people and businesses when we can from significant runoff events that pose a threat to human health and safety. Further, it is important to understand that the volume, timing, and location at which runoff enters the system significantly impacts the timing and amount of water released from the reservoirs. Each runoff season or flood event is unique. Care should be taken when comparing one event to another. We at the Corps of Engineers understand the importance of the Missouri River in providing water for irrigation, municipal, and industrial uses throughout the basin. We operate the system to meet the water supply requirements of the basin to the extent reasonably possible. There is presently and will be adequate water in the reservoirs, in the river reaches between the reservoirs and below the system to serve all of the water supply needs. I want to remind everyone that the Corps of Engineers does not provide or guarantee access to the water. Maintaining access to the water is the individual facility owner-operator's responsibility. Further, we will continue to meet our statutory obligations to operate the Missouri River mainstem reservoir system for its authorized purposes, as described in the Master Water Control Manual. We will also continue to comply with all laws and the provisions of the 2018 biological opinion. The final 2023-2024 annual operating plan was posted to our website last month. You can find a copy of the AOP on our website. Lastly, the runoff forecasts and projected reservoir releases and pool levels that my staff will be discussing are based on the best available information. Actual conditions may be different. This concludes my opening remarks. Thank you very much. I will now turn the discussion over to Mike Swenson.
Okay, thanks, John. Yeah, Ryan Larson was unable to join us, so I'm going to cover his part. You can go to the next slide. The 2023 calendar year runoff summation for the Missouri River Basin above Sioux City, Iowa was 30.4 million acre feet, 118% of average, which is the 34th wettest annual runoff for the upper basin in 126 years of record keeping. The 2024 calendar year runoff forecast, which is shown in red here for the upper Missouri River Basin above Sioux City, Iowa, is 20.1 million acre feet, 78% of the average. You can move on to the next slide. The below average runoff forecast for 2024 reflects drier than normal soil moisture in the northern portions of the basin, below average mountain snowpack, and below average plain snowpack. As seen on this slide, we are expecting below average runoff during the high runoff periods of March through April, when the plains snowpack typically melts, and May through July, when the mountain snowpack typically melts. Next slide. These graphics show the departure from normal snow water equivalent, or SWE. SWE is the amount of water contained in the snowpack that would be available for runoff or to replenish soil moisture when the snow melts. The December 24th graphic shows the lack of snowpack in the basin, with almost the entire basin showing a deficit in the SWE, especially eastern, south, and North Dakota, where differences from normal ranged from minus 0.1 to minus 0.5 inches of SWE. Since December 24th, a couple of winter storms have tracked through the lower basin and South Dakota, while the January 9th graphic is showing 0.25 to about 0.5 inches greater than the normal SWE over portions of the basin. These areas tend to have less SWE during the winter, so the total SWE is still low. The northern portions of the basin, where snow typically accumulates, fell further behind the median, with areas of a quarter to a half an inch of the normal SWE expanding. You can move on to the next slide. This graphic provides a status update on the Upper Missouri River Monitoring Network. As more stations were completed last year, there are now 170 of the 540 total sites completed and transmitting data. Each station is designed to measure meteorological data, precipitation, snow depth, and soil moisture, and soil temperature at 5 different depths. Data provided by the stations help improve products such as the plain snow map shown on the previous slide, and they help inform our runoff forecast. Next slide. The mountain snowpack is accumulating at below average rates in both the above Fort Peck and Fort Peck to Garrison reaches. The mountain snowpack in the above Fort Peck reach is 49% of average, shown in the left graphic, and compared to the highest and lowest peak snowpack over the last 30 years, as well as the average snowpack for that reach. The mountain snowpack in the Fort Peck to Garrison reach is 60% of average, shown in the right graphic, and also compared to the highest and lowest peak snowpack over the last 30 years, as well as the average for that reach. It is important to note that close to 50% of the typical accumulation period has elapsed. A majority of the mountain snowpack typically falls from January 1st to mid-April. In summary, the 2024 calendar year runoff forecast is 20.1 million acre feet, 78% of average. I will now move on to talk about the reservoir studies. You can go to the next slide. Actually, the next one after that. Gavins Point releases.
Back one.
Oh.
There you go.
Gavins Point releases reached the winter rate of 13,000 CFS in early December. releases were increased up to 15,000 CFS on Monday this week in anticipation of the cold weather, which has caused and will continue to cause extensive ice formation. Our current plan is to hold releases at 15,000 into next week and then reduce back to 13,000. That may change depending on weather and river conditions. Gavins Point releases are expected to remain near 13,000 CFS through February, but will be adjusted as needed due to cold weather. At Garrison releases were set at 16,000 CFS in December in anticipation of the river freezing over in the Bismarck, North Dakota area. The river stage typically rises several feet in a short period during the initial freeze-in, and that's likely to happen over the next several days. Once the river ice has stabilized, releases will be gradually increased, reaching 25,000 CFS in early February. That's downstream conditions permitting. Moving on to the system storage slide here. System storage is currently at 52.8 million acre-feet, 3.3 million acre-feet below the base of the annual flood control zone. Moving on to slide 23 here, and looking at the upper three reservoirs, Fort Peck and Oahe are currently 4.5 and 7.3 feet below the base of their respective flood control pools. Garrison is 0.8 feet above the base of its flood control pool. In January and February, releases will be adjusted so the reservoirs are better balanced with respect to the percentage of water in their carryover zone prior to the start of the runoff season. The reservoirs will start this year's runoff season approximately 3 to 4 feet below the base of their flood control pools. And now moving on to talk about the monthly simulations. The basic simulation uses the runoff forecast that I just discussed. Due to the amount of variability in precipitation and other hydrologic factors that can occur over the next several months, we also develop an upper and lower runoff that are then used in the upper and lower basic simulations. These simulations provide a range of reservoir elevations and releases that may be expected under the different runoff scenarios. The discussion to follow will focus on the basic or most likely runoff forecast. Information on the other runoff simulations is posted on our webpage. So now here on slide 24, the service level is used to determine releases from Gavins Point Dam to support navigation, and in combination with the bank stabilization and navigation project to help provide downstream navigation channel. The navigation service level at the start of the navigation season is typically based on the March 15th.
George, go back
Yeah,
one.
can you go back?
There you go.
The navigation service level at the start of the navigation season is typically based on the March 15th system storage. Under the basic simulation, we would be providing full service flow support at a level 500 CFS below full service for the first part of the navigation season. For that level of service on the basic simulation, Gavins Point monthly average releases range from approximately 29,000 to 34,000. The service level for the remainder of the navigation season and the navigation season flow support length are based on the July 1st system storage. Under the basic forecast, flow support for navigation would be reduced to approximately 2,500 CFS below full service after the July 1st storage check. There would be a normal 8-month navigation flow support season under the basic simulation. You can move on to the next slide now. The studies also include test flows from Fort Peck Dam. The test flows would assess the potential benefits of alternative management scenarios for the pallid sturgeon. One of the criteria for running the test flows is for the reservoir to be above elevation 2227, which is 2 feet above the spillway crest. As shown on the earlier slide, Fort Peck is currently above elevation 2229. There will be 2 pulse periods with flow targets at Wolf Point, Montana. The target flows at Wolf Point will be similar to observed flows in some recent years. The water moved from Fort Peck would be captured in Garrison The releases from Gavins Point are unaffected by this operation. And moving on to the next slide. Energy generation at the main stem dams in 2023 was 7.9 billion kilowatt hours. The long-term average is 9.4. The forecast for 2024, again, under the basic simulation, is 8.7 billion kilowatt hours. And then you can go to the next slide, which shows the Missouri River Basin weekly update, which is found on our website at the address shown at the top of the slide. This webpage gives a good general overview of the current conditions in the Missouri River Basin and is updated weekly, usually on Tuesday morning. That concludes my comments. I'll give it back to John, or do you want to go with Paco?
Paco, we can begin the question and answer session here. So why don't you take that over, please?
Okay. So we have a question and answer session here. We'll now field questions from congressional delegation members, tribes, state officials, local government. After we've completed questions for these stakeholders, we will move to the members of the press. Again, beginning with congressional, tribal, state, and local government officials, as well as emergency managers and levy sponsors, we will field questions by state in alphabetical order. Remember to press *6 to unmute your phone, and you may need to unmute from your computer screen if you've used the webinar to call in. Please be sure to state your name and the organization you represent before asking your question. We will move to, so now we will begin. So we will start with Iowa. Any questions from Iowa?
No questions from Congressman Randy Feenstra's office.
Thank you, sir. Any questions from Kansas? Kansas. Any questions from Missouri?
No questions from Missouri.
Okay, thank you, sir. Any questions from Montana? Okay. Any questions from Nebraska? All right. Any questions from North Dakota?
None from North Dakota.
Thanks, sir. Any questions from South Dakota? And any questions from the great state of Wyoming? Okay, we'll move into round two. If there's any questions from the media, we're going to go ahead and do it by state as well. So we'll start with Iowa. Any media questions from Iowa? Kansas? Missouri? Okay, Montana? Nebraska? North Dakota? South Dakota?
This is
And
Jody.
Wyoming. Oh, go ahead.
This is Jody at DRG Media Group in Pierre. Just wondering, and if you covered it, I had to step away for a little bit, so I apologize if this is repetitive. As far as the ice levels that you're seeing on the upper part of the Missouri River, are you seeing any areas of concern yet, or has winter been mild enough that we aren't seeing issues with ice and ice jams just yet?
Thanks, Jody. This is John Remus. We're not seeing anything that we would consider out of the ordinary at this time.
Good.
The only thing is it's a little bit later than normal.
Okay. Thank you.
Thank you, Jody. That leaves us with Wyoming. Okay, no questions from Wyoming. Okay, that concludes this call.
Just a
again,
second,
we will-
Paco.
Yes.
I got some closing remarks here.
Oh, okay.
Yeah, everyone, just again, just thank everyone for tuning in, and another thank you to both Doug Cluck and Kevin Lau for their assistance on this. As we move through the winter and into the spring, I encourage everyone to monitor our website for the latest information on releases and pool levels. The slide that Baco's showing right now has our contact information, and these slides will be posted to our website as well. I will offer one last chance for questions before ending the meeting, so we'll give people a little chance if there's a at-large question or people can get unmuted in time. Hearing nothing, I thank everybody again, and this will end the call. Our next call is scheduled for February 8th at 1 o'clock. Thank you all. Have a good day. Stay warm.
Thank you, John. We appreciate everyone's participation today. Thank you. Bye-bye.